Let's see our multi-agent in action now. Writer, reviewer, planner, and publisher agents working together like a real editorial team. Hello friends, welcome to Agentic Navigator. Today I'll show you how to build a multi-agent system using LangGraph, step by step. This multi-agent system behaves like a real content team. Writer creates article, reviewer reviews it, planner decides next step, publisher final output. So why are we using LangGraph? Because LangGraph is a kind of framework which provides low-level features from developing a single agent to develop and orchestrate multi-agents in a reliable way. LangGraph enables multi-agent collaboration, shared memory, dynamic decision-making, loops, retries, and even human-in-the-loop workflows. So instead of building simple chatbots, you can build intelligent systems that plan, reason, and improve autonomously. Let's start with first point, setting up the environment. Open your VS Code IDE and create a file called requirement.txt and mention the names of all the 5 packages as shown here. And then run pip install command to install and set up the LangGraph environment. And that's it. Your LangGraph environment is ready. Next, create a Python file. For example, we have named it as multiagent.py file. And then import these required packages as shown. Now let's start with second point. Configure the LLM, large language model. Before we configure, it is very important to understand why we need an LLM. Because the intelligence behind every agent is the LLM. It's the LLM that enables an agent to plan, reason, and make decisions. So let's define LLM for our agent in code. Here we initialize the LLM using chat OpenAI function. We are using the GPT-4o mini model, setting creativity with temperature is equal to 0.7 and securely loading the API key from environment variables OpenAI_API key. Let's now get this OpenAPI key. To get LLM API key, we need to log into platform.openai.com. As you can see, we already created one key which we will be using in our project. But if you want, you can create other keys as per your requirement. Once you have created API key, just copy it. Now we need to create .env file and place your API key in this file as shown here. Make sure that you put the name as OpenAPI_key. So now our LLM is fully configured to read API key from .env file via this open_API key environment variable. Let's start the most exciting part. Design multi-agent workflow. Nodes, edges, and state are the 3 core building blocks of LangGraph. Without understanding these concepts, it's almost impossible to design even a single agentic AI workflow in LangGraph. Let's have a quick look on them. Nodes are the programming logic where the actual work happens, usually a Python function. Edges are the paths that connect one node to another. State are the shared data that flows between all nodes in the workflow. Now that we understand nodes, edges, and state, let's move on to the core requirements of a multi-agent system. A multi-agent system requires independent goals, independent prompts, independent decision-making, message passing, and dynamic routing. To create an agent in LangGraph, we need to create a node. A node is basically a Python function which has the complete logic for the agent to perform. So basically, we need to write 4 functions for all our 4 agents. If every LangGraph workflow starts with a state, this is the shared memory that flows between agents. We define it using type_dict object. Here, messages field has conversation history, status field has draft, review, revise, and publish, topic field contains what we are writing about, and content field has the article itself. This is the shared canvas all agents work on. Let's start creating our first agent, writer. The writer agent has one job, write a well-structured article. It receives the topic, generates the article, and updates the state. Notice something important at line number 38. This agent is invoking our LLM to plan and reason. If you see the prompt starting at line number 34, the writer doesn't know about the reviewer. It doesn't know about the planner. It just does its job. That's what makes it an agent. Now let's start creating our second agent, reviewer. The reviewer agent is independent. It doesn't rewrite the article. It critiques it. It gives 5 bullet point review comments, a quality rating out of 10. This rating becomes the key signal for the planner. Again, the reviewer is not a step. it's a role. Now let's start creating our third agent, Planner. This is where the workflow becomes truly multi-agent. The planner reads the reviewer's output. It extracts the rating and then decides if rating 7, send back to writer, else send to publisher. This is dynamic routing. This is autonomy. This is what transforms a pipeline into a multi-agent system. The planner is the brain of the workflow. Now let's start creating our fourth and last agent, Publisher. The publisher agent is the final step. It extracts 10 key points and produces the final summary. It doesn't care about the writer. It doesn't care about the reviewer. It only cares about publishing high-quality output. This separation of concerns is what makes multi-agent systems scalable. Now, let's compile and execute the complete workflow. Now we wire everything together using LangGraph. So here we are calling addNode method to associate agent function to a node. For example, first addNode method means the node name is writer, and when this node runs, it will call the writer agent function. Similarly, reviewer calls reviewer agent, planner calls planner agent, publisher calls publisher agent. So remember this clearly. addNode connects a node name with the Python function that should run for that node. Edges in LangGraph define the connection between nodes. They control how the workflow moves from one agent to another, creating the execution flow of your AI system. Now we define the flow using graph add edge method. The first add edge method means the workflow starts from the writer node, then writer to reviewer, reviewer to planner. So after the writer creates the draft, the reviewer reviews it, and then the planner decides the next step. Finally, the last graph add edge method connects publisher node to end node, which means once publishing is done, the workflow ends. And at the end, graph compile method converts this graph into a runnable application. Now we are ready to invoke this multi-agent workflow. We will pass the topic called artificial intelligence and machine learning. Now let's test our whole multi-agent system with some real data. Let's hit the Python command to run our multi-agent app. As we can now see, the writer has started creating drafts on the provided topic, AI and ML, and waiting for reviewer. Now, the reviewer has reviewed, and the planner decides. If needed, the writer revises. Finally, the publisher publishes. This is a real multi-agent editorial team running inside your Python code. Whole code is uploaded to GitHub and link is shared in description for your reference. Building multi-agent systems can feel challenging at first. So if you get stuck anywhere, drop your questions in the comments. I'll do my best to help you as quickly as possible. Subscribe now so you don't miss the next video in this series. Thanks for watching and I'll see you in the next one.